Thank you for your interest in STAAD.Pro Connect Edition. This video is a part of the series of excerpts from the Increase Your Digital Productivity with STAAD.Pro Connect Edition live event held at Bentley's Digital Advancement Academy located in Pune, India. This excerpt is titled Integrated Steel Connection Design with STAAD.Pro Connect Edition. The presenter is Bentley colleague Kaushal Agarwal, Technical Support Engineer, Structural Design Engineering Analysis.
Okay, before I move further, I want to discuss one of the very interesting feature of STAAD.Pro. I'm not sure whether you've been using it or not, but there's a feature inside STAAD.Pro which we call as connection tags. So connection tags is where actually I can define the end conditions, the connection end conditions of a particular member. I can define in a separate XML the capacities of a particular member to take those forces using an XML schema, and I can run that inside the STAAD.Pro itself to understand the overall stability at the connections. So there is one module which we have dedicatedly for the connection design, which we will cover, of course. That is a RAM connection inside STAAD.Pro itself, but there is one parameter also to check overall stability of the model inside, at the connection points. And we had these facilities, I'm not sure from years, but it's not been used. So let's look at that, how we can actually assign the connection tags and what it does. So first of all, the connection tags are available under utilities. You need to go to the utilities, and here we go with the connection tags. The connection tags actually work on a schema, okay, and some equations. So first of all, I'll just give you that schema, where the schema is coming from. So this is a sample schema that has been provided. There are several categories regarding that. We have moment connection, we have shear connections, and these are the equations that actually it checks for the connection design capacity at each and every connection. What I need to provide here is the moment carrying capacity and the shear carrying capacity of the sections which I have in the model. So whatever the section I have in the model, I need to provide here and with the capacities, with the shear and the moment capacities. So shear, of course, in the Y and the FX, both I need to provide over here. So you can see that I have provided that capacities, the moment capacities, and the shear capacities over here for several of the sections. And let me define one of them now, and let's say what this tag does. So let me select this as a member. So this is the first member which I've selected. I can go to connection tags, or I can say right click connection tags and assign connection tags. Okay, so selecting a member, right clicking, saying assign the connection tags, and let's say I want to assign some of the connection tags to it. Okay, hold on a second. Right, so right click, here we go, and I'm defining this as a moment connection, and at the start end only, because I will actually assign him. I want to check the capacity here, and I want to check the capacity of the overall beam over here, wherever it is connecting. So this is actually the start end, and I'll assign it to the start end. This is the first one where I've assigned, and second I will select this beam and I will assign this to only at the end. So you can see that the blue part of this beam is actually here. So I will say new again, and this is again going to be my. So you have two types. You can see the moment on the shear, and I can assign that on the end, and I'll say assign. So I've assigned just to a single beam, just to show you, okay, but it can be done for the whole of the model. And after that, as per the schema which I just showed regarding where the equations has been written against which it will check, and also the capacities where I provided of these sections, I can, let's say, check these the connection tags. I can select all of the loads or some of the loads which are of interest. So this time I'll say select all, and I'll say check, and you will be given as in table, for these sections. So you can see the beam number, the sections that has been used, and you can see the connection capacity that has been provided by you in that XML schema. Okay, so this is where the capacities has been given. First of all, the moment check has been performed, and I can see that okay, yeah, my member failed for the moment check, but it has passed for the shear check. And if I look at the overall check over here, I can see it's failed. Okay, this can be done for an overall STAAD model to understand the overall safety of my structure and the connections. This facility, as I said, has been available from years, but I'm not sure why not been used. But I think from this session onwards, we can use. So RAM connection actually, is a connection design, steel connection design software in particular, and it has totally integrated with the STAAD.Pro. So the part is that whenever we try to design, the connections, the steel connections, first of all, if I'm using any Excel sheets, I need to export out all the loads, from an analysis software and the interfaces, and then I probably need to, run it. And that actually a manual interface. I need to take out the loads. I need to take out the sections at each and every, connection that I need to do. That much work we need to do. But inside this, that is totally integrated. I just press a button and all that information directly exported in RAM connection. What RAM connection does, so you can see some of the outputs. You can get the outputs in 3D. You can get the outputs in the form of a DXF. And the most important benefit, which I see as in using RAM connection, is its calculation sheet. It's very impressive. It actually something like I've designed the connection as per my hand calculations. I have that kind of a report that can be generated from RAM connection. What are the connection types which we handle inside RAM connection? So you can have a look at that. I try to provide as much as detail over here. So these are the different routines which we have in the terms of beam column flange connections. You can see the picture which probably clarifies a little bit more. The beam column web connections, the column splice, column cap connections, beam splice connections. In case you have chevron braces, even those chevron braces can be designed. The vertical cross braces can be designed. The beam girder connections, column, beam, and a brace in the vertical plane. If you have that, even that can be designed. Base plate connections that can be designed. And very recently we added horizontal bracing also. So in case you have a horizontal bracing, even that kind of a connection can be designed inside RAM connection. And also tubular truss connections are now part of RAM connection also. This is one of the most important interesting part of RAM connection. So let me talk about how the actually RAM connection works. So I'll just pick up a single routine from here. So you can see that I have almost 12 routines, 12 different types of the connection type which I've defined. But under each and every connection type, I can have shear connection, moment connection, and inside shear connection also I can have several types. So let me discuss one of the type here, which is BCF here, which is beam column and flange connection. Under BCF connection, I have shear connection. So shear connection can be all of different types. Like say, I'm using double angle. I'm using the different CT the angles. I can use the standard T. I can use single plate. I can use bent plate. I can use end plate. So there are several types inside the shear connection itself. And if I talk about the moment connections, they can be directly welded. I can provide moment angles, flange plates, or moment T. Or I can have a combined action, which is shear plus moment, which is my moment and plate connections, and moment and plate. If you have tapered kind of a section, so even we can design the moment and plate knee type of the sections, knee type of the connections. And of course, the base plate connections, I already said. Base plate connection, you can see two types here. One is simple base plate, and the other one is with a gusset. So if you have a bracing which is coming out of the base plate, even that kind of a connection we can handle. Okay, so let me just go through a little bit more into details of in terms of the how or which code it supports. So you can see the American Design Code 2015, which is AIC 360 2005, 2010, and 2016 code also supported both the methods ASD or LRFD, seismic provisions from the AIC 341, the pre-qualified connections as per 358. Euro codes with annexures, any kind of annexures you can use inside RAM connection, the Chinese design code, BS design code, and recently, very recently, we have added the IS 800 2007 code. So we'll just have a look at it. But when I say that IS 800 2007 is implemented, let me tell you it has some limitations also, because I need to tell you very openly here that what has been implemented and what has not been implemented. So first of all, the favorite questions probably from the users is whether chapter 12 is implemented. It is not. It is not implemented inside RAM connection having IS 800 2007. It is not implemented, and also as we also understand there is no specifications specifically from an Indian standards regarding connection design wherever it is required, because we have a very good library, as you can see, that we actually conform to a lot of international codes. We understand that what are actually the checks that are required for a connection, so that we can say that it is a passed connection, it can be used at the site. So we understand that, and if those specifications are not available inside Indian code, we had to refer some of the additional references. So additional references we have to is some of the books involved, some of the writers like the N. Subramaniam. There are some examples available from S.S. Bhavikati inside RAM connection, and also there is Euro codes we had to refer as an international design code wherever there is no specification from Indian design code. Okay, so bear in mind when you try to use RAM connection, it is with these conditions. Okay, let me just let's just have a look at what can be done. So after analyzing my model, I will click on this connection design. Here we go. We have a dedicated tab here for the connection design. I can click on that. And let me choose one of the connections which probably I want to design. So just show you that how it looks. So it is actually a connection between a column and a beam. Actually, the column looks weird here. Probably I'll choose another one. Okay, so here we go. So this is a kind of a connection where the beam flange is connecting to the column. Sorry, the beam actually connecting to the column flange, and I can select that using whatever I've did here, and I can select my code or probably the design, probably the load combinations for which I want to design this connection. So I can click on that and I can just have a look at the combinations for which I want to design it, and I'll say just show the combinations and do it only for the combinations. Let me select my IS 800 2007. From here, I will select the template, which is actually it is kind of a moment connection. So I will select a moment and plate connection with a haunch, and I'll select a flush type, and I'll say okay. So the ratio which is it's showing is more than 1, which is not good. It's 1.61. I'll double click on that to let me understand what is wrong here. Okay, so you can see the plate size is big enough, and perfectly the reason we can see that I have assigned myself some of the weaker sections as in the column sections. That's why it's actually failing in. So I probably need to increase so this is what it is conforming to the connection tags. That's why I just shown this connection, because in connection tags it has been shown that the moment connection will fail actually, right? And so this what can be confirmed over RAM connections also. Let me choose a connection probably that is of good size. So this is another connection where you can see that I have sufficient size of the column and the beam is connecting to it. And let me design this connection. So status is okay. I can double click on that and you can see that connection has been passed. So the interaction ratio, as you can see over here, is 89. though we can change a lot of things over here on the right on the left hand side. So whatever the change actually I will do on the left will directly have an effect on the design ratio. So let's say if I try to change the plate thickness, which is at this point of time is optimized to 10 mm. If I just increase it just for sake of just to showing you to let's say 20 mm, so you can see that effectively at the same time I have a change in the interaction ratio. That means the recalculation has been done at the same point where I do the change. So let me put it back. So if you talk about the bolt library or the ankle library, we have a very good library again coming in from the Chinese, Europe, India, United Kingdom, United States. Huge library is available, confirming to the grades, which is 4.6 to 10.9, and different diameters. As I said, the best part of this kind of the connection is its report. But let me tell you one more part, which is actually I have assigned this connection as to be type of with haunches. So probably I need some haunches. Not in this case, by the way, this is pass, but if I want to assign it, I can assign an haunch. So you can see that an haunch can be assigned. Of course, in case you need some stiffeners, we can assign some stiffeners also to full depth, let's say at the bottom also. So it understands that it needs to be added at the point where there is a haunch. So it is added at that plate. And of course, in case your column is failing and buckling, you probably need to provide some doubler plates. So you can provide some doubler plates also. So this is something can be done. So whatever you do here, that will have an effect on the 3D model, that will have effect on the interaction ratio, that will of course have an effect on the DXF drawings also. So it has a very good understanding of developing some DXF drawings. You can see over there. So whatever you did with this with your connection model, that will be effective in the DXF drawings. And this can be a starting point of your delivering the shop drawings. Well, let's have a look at the report. So what I'm seeing here is a summary report, and even in the summary report, I can see that the clauses number, which it has confirmed to the value which isn't there in the connection design, and the minimum and the maximum value. So it is falling under that limit, and it is checked against this clause. But if I can have a look at this in detail, but in case I need more details, I can click on this show formula, which will actually give you the whole of the calculation that it has to perform to design a single connection. And it's a huge report. So let me zoom into the area, and you can have a look at that. These formulas are from where these formulas are coming in, from where this 50 is coming in from, and this 160 is coming in from. So you can have a look. And as I said, wherever it is required, we had to use some of the additional specifications. But of course, here you can see that in the compression zone column, web panel and share, this is where we have used the Indian codes. So wherever we had no specifications available inside Indian, we had to choose the international design codes to refer to. One of the other ability of this, because I just showed you a single connection probably, but let's say I want to design, because this is the kind of structure which we design. Probably we have number of connections. We have thousands of connections inside our pipe rack. So what we'll do is we can have a group also. We can group the connections. We can edit the group. We can actually have a single report probably I want to develop for a group. So what I'll do is here I'll just say select all the joints which are available inside this model, which are column, beam, and brace joints. So it will go on and identify all those points. And what I can do, I can go for the gusset. Let's say this time I'll choose the American Design Code double angle CBB connection, and I'll say OK. So there are 34 connections it has identified, I can design them together. So let's just wait it to complete. So it has completed 34 connections. You can see that, and I have some of them which I need my attention. I can see that some are not green, some are, some of them are red, which probably need my attention. I need to go into that and have a look why those failed. But let's have a look at one of them. What kind of a connection can be handled by RAM connection. And of course, you can have a report on that. You can have a report, you can have a DXO drawing that can be developed. Perfect. So I think I am completed.
The next excerpt in this series is titled Design of Column, Wall and Beam using STAAD Advanced Concrete Design. A link to this video is provided here and in the description below. Thank you for watching.